Hello and welcome to another exciting Breakfast with Unity. I'm your host, Max Moreau, and I'm feeling better today. I was actually sick on Friday and over the weekend, and so it was kind of sucked, but I'm back, and hopefully this will go pretty smooth. This might be a two-parter. It is slightly involved, but we'll see how things actually go. So, what we're doing today is a target lead indicator. Now, what this is like is if you have an object moving in space and it's moving forward and you had a projectile weapon, say something that fired like a round that moves 50 meters per second, what it would do is it would calculate where the enemy will be by the time that the projectile has moved the distance of the enemy. And so that we can basically shows you where the player should aim if they want to hit the enemy if the enemy maintains their current velocity and heading. So this happens pretty commonly in games. Elite Dangerous has this for the ballistic weapons, and actually it's similar to our ballistic setup, except for this one doesn't deal with gravity. It just deals with the distance and the time to hit the target. So let's get started. I'm going to create a. Should we create a fresh scene? Yeah, let's create a fresh scene. We might redo and do something else later. I'm just going to save the scene right now. Target lead indicator, and we're going to put this into our folder that I made for this target lead indicator to save. So we're going to need an object. This is our target, so I'm going to make it a sphere for right now. And we're going to need some way to actually make this sphere move. I'm going to create a what am I going to do? Yeah, let's just start by making something that's basic and works. So we're going to just use gravity on this thing. I don't know. We need it to move some way, and I prefer to use a rigid body so that we can do the simpler case. All right, we're going to need a rigid body move script. What do we have for rigid body? Rigid body. Drag rigid body. That's not good enough. Do we have... I'm going to actually give it our controls from... Where is it? Basic 0G. Where's the 0G thing? G. 0. 0G. Here we go. So we have in here... I'm just going to save this for right now. A script called 0G movement, 0G rotation. Perfect. So I'm just going to put 0G movement on this sphere. We're just going to go into our target lead indicator, and we're going to put 0G movement, add component, 0G movement. So what are we going to do? So this gives us a forward and horizontal axis where I'm just going to see how this works. So I'm just going to hit play. And hopefully if we hit like W and A... Oh wait, there's no rigid body. We need to add a rigid body. Physics, rigid body. Probably should have that in the 0G movement, but I'm not going to worry about it for right now. Save, play. Oh, we don't want gravity. That's bad. As it's called 0G movement, you would expect that you would not want gravity. What am I doing? I'm going to put a light in the scene. And we're going to hit play. And I'm going to just move it to the left. There we go. And move it to the right. And we can move it forward and backward. Good. That'll be good enough for our test. I'm going to go ahead and put the main camera in here. And I don't know why I made a point light. I didn't want that. I wanted a directional light. There we go. So now we can move this thing around. It's a little bit wonky, but it'll be good enough for our purposes. So, what we're going to do now is, should we do this on the object itself, or should we do it as a separate thing? It doesn't really matter, so let's do it as a separate thing. So I'm going to create another 3D object. Let's just create a cube for right now so that we have some differentiation between things. 0.5, 0.5, and 0.5. And this is going to be where our lead indicator is. And we already have a script that we're going to use to bring this into a UI space, but let's just get the cube working the way that we want it first. So what we're going to do is we're going to create a new script, C# script, position based on target velocity. So we're going to first just display the target velocity at 1 second in and see how this goes. So, as I said, this might turn into a two-parter. It's already gearing to do so. But we're going to get something working first. So, all this is going to do is just position itself based on the target velocity. So we're going to need a target, so public, and I'm going to make it a rigid body explicitly public rigid body target, and we're going to in fixed update, because it won't change between those values anyway, we will set transform dot position equals target dot position plus target dot velocity. And this should hopefully work as it is. So I'm just going to put this on here, and we're going to hit play. We're going to see what happens. First, we're going to get an unassigned reference exception because the cube is not in the position of the sphere. So we're going to change that real quick. We're going to put, first, we're also going to remove the collider. We're going to remove the box slider, and we're going to give it the target of the sphere. We're going to hit play. So now if we move the sphere, you can see that based on the velocity, the target goes out further or less. And if we move it in 3D, we get the same effect, except for it moving in 3D. Yay! So that's good. That's a first step here. So now the difference here is what we actually want. This gives us the position that the object will be exactly 1 second after moving this way. So if we actually take the time to meter this out and just kind of estimate here. So if we do 1001, see how it moved through. So 1001. And even if we move faster, 1001, see? So this is all well and good if your projectile always will take 1 second to hit your target. So if you're doing lerp projectiles, which I don't think many games do, but you could, this would work just fine for you. You just set the time that you would want. Actually, if you want to set a specific time, let's actually add that, because we're going to need it or some equivalent soon anyway. Public float time. I'm just going to call it equals 1.0 f, and all we do is we multiply times time. And so now if we wanted to, we could set this to half a second by just setting the time to 0.5. And in half a second, which is really, actually I should probably do 2 seconds as an example, because half a second is tough to measure. 1,000, yeah. 1,000, yep, that's a half a second about, but if we do 2 seconds, it'll be a little bit more explicit as to whether this is working or not. So, all right, remove that. 1001, 1002. Yep, looking good. So we can use the script directly, or we can have another script that kind of positions things based on a different value. And we're probably going to do that. I'm going to go ahead and create a new script for the actual final thing here. But this is a good starting point so that you understand basically what we're doing here. All we need to do now is basically calculate the timeout. And so let's see. Do I want to? Yeah, let's make this as a separate script. Create C# script. We're going to call this target lead position. And we're going to put this on our cube. We're going to get rid of the current position based on target velocity. And this is going to be similar to position based on target velocity, though. So I'm going to actually just copy the contents of this real quick in here. Position HUD. Wait. There it goes. I swear I double clicked that. All right. So paste this stuff in. So we have a target. We have a time. This is actually going to be changed to projectile velocity. And we'll default that to 1. And so what we're going to do is, this is our basic calculation for it with the time variable. But we now have a velocity variable, so we need to figure out how long it will take to get to our target. So we need the distance in the first case. So to get the distance, all we need is float distance to target equals, and I'm just going to base it on our camera.position. So we're going to just pretend the player is the camera. You could change this to a tag or something else later, but this will work for our purposes right now. Camera.main.position. No. Camera.main.transform.position minus, what is the other thing? It would be our target.position. This will give us our the relative vector, and then we just do dot magnitude. There we go. And we have a distance. So we have the distance to target here. There is actually a shortcut function that you can use here if you prefer. I think there's a vector3.distance. It just does exactly the same thing. You just give it the two variables. So if you prefer that, you can use that. I use the other just because I am trying to teach you guys through osmosis how to do vector math, and this stuff is really useful. And I know that I'm probably not doing as good a job as I want to be doing on this, because linear algebra is super useful, and it's actually super easy, but it's taught very wrong, and so a lot of people think it's really complex, and it's not. So anyway, I'm just gonna leave it as that. So what are we doing? So we have the distance to target, and so the time to target, float time to target, is equal to the distance to target divided by the projectile velocity. And so all we need to do is we multiply in time to target here. And theoretically, this will now show the distance that it would need to be in advance to here. So this, God, that was a bad sentence. I don't even think I understand what I said there. Said. Wow. Okay. Mornings. Blah, blah, blah. I should have talked more before I started doing the show. So, if this works right, this should give a much bigger lead, even though we have it set to 1 velocity, because it's a distance of about 15 units away. So it should be 15 times. Yeah, you can see this much further now. So we're using an incredibly slow projectile. If we were to fire this projectile, I'll show you what it would do. We've got spawn on button. So I'm just going to put spawn on button on our main camera. And we're going to make a object that moves very slowly. We're just going to create a, what have we not used? I guess we'll use we'll just use a sphere. It doesn't matter. And I'm just going to make it smaller. 0.5, 0.5, and 0.5. We're going to call this projectile. I'm going to create a prefab of it. And we're going to give it the move forward script and set it to a speed of 1. So that's good. We're going to just apply this to our prefab, get rid of the one in the scene, go to our main camera, add our projectile here. And if we hit play and we shoot, we'll see just how slow a 1 unit per second projectile is. It's quite slow. So let's see if we got this basically right in this incredibly slow case. This is going to be kind of hard to test, but I'm going to see if we can do it. All right. So as soon as this crosses the threshold here, in theory, if we fire right as it enters the center of the screen, bam, this should hit the enemy at about the right time here. Oh, it was a little slow. I might have fired at the wrong time. Or we might have a math error. Let's see. Maybe I should give myself a reticle real quick. Let me do that real quick. I'm just going to go to our reticles test, save all, and I'm just going to grab this site. Actually, I'm just going to grab this whole canvas. Copy. We're going to go into target lead indicator, paste it in here. And we're going to get rid of the target box. We're just going to leave the sight. So now we know when it actually crosses our threshold in the middle there. The sight is just an image that we're just placing on the screen. It's nothing fancy. If you need to see how to set that up, it's in the projectile. It's in the target reticle example. Come on. All right, here we go. So we fire. Yeah, it looks like that's going to miss. That is unfortunate. Let's try it with a higher value and see what's going on here. First of all, I just want to make sure the cube only has, sorry, the projectile only has one, yeah, move forward, okay. Huh. Must have done something wrong in my maths. That's okay. Let's just look at it for a few more minutes and then we might turn it into a two-parter, although we're really close right now. Let's make it so this thing travels faster. Let's make it 5. And let's make it so that the cube has the proper projectile velocity set in here. We'll hit play. And fire. I fired a little late. Oh, it hit it. It actually had physical contact with it. That's interesting. I forgot to turn off the colliders, and since it's a physics object, it actually worked out. Let's take a look at this one more time. Fire. I think I fired late on, although that looked like I fired early as for, so there must be something that I'm doing wrong. Let me just check the comments real quick, just in case I've done something like not noticed a problem that everyone else has noticed. Stay on target. We're too close. All right. So let's look at our math here. Distance to target equals camera main dot transfer dot position minus target dot position. Target dot position dot magnitude. This would be with the distance. Distance to target divided by projectile velocity. This is correct. Target transfer dot position plus target dot velocity times time to target. Ought to be right. Alright. I'm going to, we're going to make it slow again. Slow, where is it? We want the cube to be 1, and we're going to make the main camera, the projectile be 1. Play. Sorry, just trying to get it to a position where we can work with it. I'm going to stop and play it again. There we go. This is a slow example. Oh well. So I'm going to fire this thing. Kerplow. Alright. Well, it hit that time. That's good. I think this is right. I think I'm just not nailing the timing just right. Let's make sure that it works when the object is moving a little bit forward too. Let's make them faster though. Let's make it 5 units again. Actually, let's make it 10 units. 10 units per second. 10 units per second. See if we can nail this thing a few times. All right. So this time we're gonna actually have it move based on the depth a little bit here. All right, that was a hit. What am I doing? Oh, I see. I see what I'm doing. It got rotated, so it doesn't control the same way anymore. So let's let's have it moving into the distance and see if we can hit it. Fire. Let's see how we did. I have no idea how we did. I got so confused by how I did that. All right. I don't think we did well, though. All right, let's just get to a position when the game has started so we can see our sphere. And let's hit play. Let's move it going out there and fire. Nope, didn't quite hit. It's close though, but I feel like something's off. Well, I'm gonna just leave it at this for now. And we might pick it up again on another episode. I'm just a little bit perturbed by that. It feels like that should just work, but there's probably something stupid I'm doing. It might actually even be working. It's just that I'm not sure how much error we have in it. So yeah, we may pick this one up again on the next episode, or I might do something else. I reserve the right to do either. Anyway, hello, good to see everyone, and glad you have enough peanut butter to fix your burnt toast. And yeah, you guys have a great one. If you have any questions, please email me, pushypixels@pushypixels.com. You can also tweet me at Drakfyre. That's Drakfyre. And thank you for watching. If you can, please donate. Cooking with Unity. Patreon.com/Cooking with Unity. Really appreciate your support. Thank you very much. You guys have a great one, and I'll catch you tonight with more Scape.